Bismillahirrahmanirrahim. Welcome back to another interesting video. In this video I'm going to discuss exercise 2.4. Here we have question number 1. If alpha and beta are the roots of x square plus bx plus c is equal to 0, then find the values of, here we are, question number 1, part 1, which is alpha cube into beta plus beta cube into alpha. So the solution for the given question will be is alpha and beta are the roots of the quadratic equations. Is alpha and beta are the roots of the quadratic equation. Here we have ax square plus bx plus c is equal to 0. Then we can write the sum of the roots. Sum of roots is equal to alpha plus beta, and we already know that the sum of root is equal to minus b divided by a, and the product of roots is equal to products of root, which is equal to alpha into beta, is equal to c divided by a. Now as we are given alpha cube into beta plus beta cube into alpha is equal to, if we take alpha beta as a common, so we get alpha square plus beta square, because from here we take alpha as a common and beta as a common. So if we take alpha beta common, so we get alpha square plus beta square. Now we can add and subtract. Adding and subtracting to alpha, adding and subtracting to alpha beta. So here we get, if we add and subtract to alpha beta inside the bracket, I mean alpha beta, we can write as it, and we add alpha square plus beta square plus 2 alpha beta minus 2 alpha beta. We add and subtract 2 alpha beta, so we get alpha beta, and from here we can write alpha plus beta whole square, because alpha square plus beta square plus 2 alpha beta is same as alpha plus beta whole square, and minus 2 alpha beta. Now we will put the values of sum of roots, which is alpha plus beta, in product of root, which is alpha beta. So putting the values of alpha beta in alpha plus beta, so we get minus c, we get c divided by a minus b divided by a into square minus 2 c divided by a. Now we get c divided by a into b square divided by a square minus 2c, 2 into c is equal to 2c divided by a. So now we can write, if we take the LCM of a square into a, so we can write a square b square minus 2a minus 2ac, and here we can write c divided by a. So now if we multiply c divided by a with b square minus 2ac divided by a, so we get a cube b square c minus 2a square minus 2a square c, which is the required 2ac square, which is the required values of alpha cube beta plus beta cube into alpha. Now here we have another question. Find the quadratic equations whose roots are 1 into 1 divided by 2, 1 over 2. So the solution for the given question is as we know that alpha and beta as the roots are 1 and 1 divided by 2, 1 over 2, so we can write the sum of the roots. Sum of root is equal to p 1 plus 1 over 2. So from here we get 3 over 2, 3 divided by 2, because 1 and 2 become 3, and products of roots is simply 1 over 2, because 1 into 1 over 2 is equal to 1 over 2. Product, we represent product by phi, so 1 into 1 over 2 is equal to 1 over 2. This is s because we can represent the sum by s. Now we know that the quadratic equation is, we can write x square minus sx plus p is equal to 0. Now putting the values of s which we call sum of the roots, and p is product of the roots. So putting the values of s is 3 divided by 2, x plus 1 divided by 2 is equal to 0. Now multiplying both sides by 2. So if we multiply both sides by 2, we get 2x square minus 3x plus 1 is equal to 0, which is the required quadratic equation. So we can write required quadratic equation. And that's all about today's lecture.